Alright, in this video we're going to talk about something called rationalizing the denominator. Basically in math, you cannot leave a square root in the bottom of a fraction. So all these examples that have a square root somewhere in your denominator, that's a problem, so we do something called rationalizing. So what is it that we can do that will make the square roots go away or cancel each other out or something like that? In all of these examples. So the first two, well, I'll talk about it with the last row. Anyway, so what you want to do is you want to look at your radical in the denominator. This is just a square root of 3. So what we can do is we can take the square root of 3 and multiply it by itself. Now the square root of 3 times the square root of 3 is just 3. If you go through the math of it, square root of 3 times square root of 3 is the square root of 9, and the square root of 9 is 3. So you can see that just by multiplying the radical by itself, we ended up with a 3, no more square root. So that's exactly what we want to happen. Now, because we are dealing with fractions, you want to remember anything that you do to the denominator of the fraction, you do want to make sure you do it to the top. So you have to multiply the top by the exact same thing. These are both square root numbers, so we can go ahead and multiply those and get the square root of 24. So we have the square root of 24 over 3. It might be tempting to try to reduce the 24 with the 3, but we can't do that because one of them has a square root and one of them does not, so you can't simplify those together. We can, however, look at that square root of 24 and see if it might be able to simplify. Square root of 24, does it break down? Any perfect squares that fit into it? 4 fits in 6 times, so we actually can. We'll take the square root of the 4 and get a 2. The square root of 6 stays the same, and then it's over a 3. Now once you have simplified your fraction and you have that 2 out front, the last thing you might look for, the 2, if it could reduce with the 3, we could go ahead and do that right here, but 2 over 3 doesn't reduce, so this will be our final answer. Alright, next example, again we have this square root in the denominator. That's the issue, we have to rationalize this. So what we're going to do is we're going to multiply the radical by itself. If you're going to multiply the bottom, you have to multiply the top by itself as well. So in the denominator, square root of 5x times the square root of 5x, I know it's just going to be a 5x. And then in the numerator, what can we actually multiply? Well, that 2 out front will just stay out front, and we'll go ahead and multiply these two square roots together. So 8 times the square root of 8 times the square root of 5x is the square root of 40x. Alright, so can we do any reducing from here? Take a look at the radical to see if you might be able to reduce it. Do any perfect squares fit into 40? And actually 4 fits in 10 times. So we'll go ahead and take the square root of 4. Square root of 4 is 2. The 10 stays the same. But don't remember, we have this 2 that's out front with that 2. So really it's a 4 square root of 10. And then over our, you also have an x right here. Because it's not x squared, it's not enough to square root, the x stays underneath the radical with the 10. All over that 5x. And just like we talked about on the last one, we can't reduce these together because one's underneath the square root and one is not, so this is as far as we can take this problem. So those are the more basic examples of rationalizing the denominator. Then we have these two examples in the bottom row here, where the difference is you have a plus or a minus, or they're both minuses, but either way. We have to do something slightly different when we rationalize this denominator. So what we're going to do is we do want to take the denominator and multiply it by itself. So that part is kind of similar, but the only thing we have to do is whatever this sign is in the middle, we have to do the opposite sign. We're going to change that. Because that was a minus, we'll make this one a plus. And then remember, whatever you multiply on the bottom, you're going to multiply the top by the same thing. Square root of 2 plus 5. And then whatever these are, I just erased everything. Alright, I just paused the video for a second. I think what I was saying was that whatever, if this is a minus, we're going to go ahead and change the sign to a plus. Make sure that these are the same sign, that you do the exact same thing on the top and the bottom of your fraction. Alright, so I think the numerator oftentimes is easier to deal with. We'll go ahead and multiply this numerator, just distribute. 4 times the square root of 2 is 4 times the square root of 2. They're not both square roots, so you can't multiply them and get 8. 4 times 5, we can go ahead and multiply that and get a 20. Over. Now this denominator, when we have this 2 terms multiplied by 2 terms, we actually will FOIL this out. So we're going to take the square root of 2 times the square root of 2 first. Now square root of 2 times square root of 2 is just a 2. Then we'll do the square root of 2 times 5, and so plus 5 square roots of 2. And now we have a negative 5 times the square root of 2, so minus 5 square root of 2. And then negative 5 times 5 is a minus of 25. So what's going to happen every time you do these? Do you see how you have a 5 square root of 2 and a negative 5 square root of 2? That's exactly what should happen. Those two will cancel each other out. And then you can look at your other terms. You have a 2 minus a 25, which is negative 23. Final answer, look to see if you can reduce your radical. Square root of 2 can't be reduced, so that's going to stay as is. If there's anything you could factor out front that would then cancel with the denominator, you could try that. For example, a GCF of your 2 terms up here would be a 4. But would a 4 reduce with a negative 23? And because it wouldn't, we'll just leave that one alone. That's as reduced as that one gets. Alright, last example, very similar to what we did on the last one. We're going to rationalize the denominator, and because of that minus sign, we're going to throw our parentheses around this. We're going to multiply it by itself, but switch the minus to a plus. If it was a plus, we'd switch it to a minus. So you just want to do the opposite sign of what you see. Multiply the top by the exact same thing, square root of 2 plus the square root of 5. Alright, now when we simplify, we're just going to, in the numerator, do your distributing. Square root of 2 times the square root of 3 is the square root of 6. Square root of 3 times the square root of 5 is the square root of 15. Over. Now the denominator, this is where we're going to do our FOILing. Square root of 2 times the square root of 2 is just a 2. Square root of 2 times the square root of 15 is the positive square root of 30. When we multiply these together, not 30, I mean 10. I'll just rewrite that one. Square root of 10. Alright, this is a negative square root of 5 times the square root of 2, so minus the square root of 10. And then square root of 5 times square root of 5 is just a 5, but because one was negative, one was positive, is a minus 5. So here we can see square root of 10 minus the square root of 10 cancels out. So you're left with just 2 minus 5, and 2 minus 5 is a negative 3. So can you do any reducing? Take a look at your radicals. The square root of 6 and the square root of 15 cannot be simplified. No perfect squares fit in. Do you have a GCF you could factor out front that would then cancel with your denominator? And because we do not, this is our final answer on this one.